Alright guys, welcome back. One challenge to recap all. This is exactly what we're going to do right now. So this is a crypto challenge and we will recap all the things we have learned so far. Beside this, I have split it up into 3 series. So the first one will be about dealing with unknown Smiley syntax. We have learned a lot in this chapter over here, but we cannot learn everything. The things we have learned so far are more than just the concepts of Smiley. So we have done a lot of huge patches into existing applications. But now we are facing unknown Smiley syntax, which is absolutely no problem for us, as we will figure out in lesson 1. So there we have to deal with unknown syntax, but we can reconstruct the functionality of the syntax simply by adjusting our knowledge on Smiley into this application. So this is freaking awesome, the things we have achieved so far. Alrighty? Okay. Lesson 2 will be about getting out those informations of this application. Those crypto informations, keys, secrets, tokens, things like this. So far we had absolutely no problems regarding to this one because most of the time we had simply already in string in there. But now we have to deal with complex objects because this is a real-world application. And printing out complex objects is nothing we can do easily within system.out. And therefore we have to find ways on how to print out or get out these information into other objects that might be able to be printed out. So this is something we will do in lesson 2. Lesson 2 is the easy approach and it's the most common used approach from my side right now. So I always recommend doing it in the easy way. There's absolutely no need to go for the hard way. The hard way, you already guessed it, will be lesson 3. And I have inserted this hard way because in the hard way, we will do an huge Smiley patching right now. So we will insert, I guess, about, I don't know, 50, 60 lines, maybe 50, 60 lines of Smiley into an existing application to achieve a certain task. So this will be ridiculous, but it will be also pretty awesome because we can see over there how much power we have regarding to our Smiley patching right now. You might not even realize this, but within the lesson 3, there you will find out. Alrighty? Okay. So therefore I would suggest let's have a look into this application. What is this challenge about and how to deal with this one? Alrighty? Let's go. Okay, so here we are back at the Ubuntu VM and now let's have a look into this challenge to see what we are facing right now. So I have already created a directory within apps, one challenge to recap all. And as always, you can find this challenge as an attachment of this section. So here we have it, and it's named AES.apk. So my well-educated guess would be this is a challenge that has to do something with the advanced encryption standard. But who knows? We have to find this out. We shouldn't guess about this one. So therefore, let's install it. AES.apk. And nice, we get our first error. Let's see. Install failed test only. Alright, so we have to provide this -t parameter to fix this. Yes, with this one we can also install test only packages. Okay, now let's see. Let's get back the screen. And here we have this lovely icon of this challenge. So let's start this one. Alright, read me if you can. And then we've got some text over here. So we cannot read it, or at least I cannot read it right now. This text has a pretty obvious signature. And this one is the equal sign at the end. Equal sign at the end points out to be base64 encoded. So base64 is an encoding which is 3-byte aligned. If we are now having a text which is 3-byte aligned, everything is working properly. But let's say we want to encrypt the text Udemy. Let's see. Udemy. 2, 3, oh, let me count once again. 2, 4, 5. Okay. Here we are having now 5 characters and we append this -n to not include this new line character at the end. So this means we are having only those 5 characters. Alright. If we now pipe this through base64, we can see we are getting an equal sign at the end. And this equal sign is some kind of padding. So we are having 5 characters, but we need to be aligned to 3 bytes. 2 times 3 is 6, and therefore within our 5 characters, there's 1 padding missing, so therefore we are appending 1 equal sign. If you're now going for Udemy, then we should have, absolutely correct, 2 equal signs. because now 2 bytes are missing. We are having 4 characters and now 2 bytes are missing. So 2 bytes padding of equal sign gives 6, which means it's probably 3 byte aligned. If we go back 1 character, then we are having, yes, we are not having 3 equal signs because we are having 3 characters in there, and 3 characters are probably aligned on 3 bytes. Alrighty? Okay, here we can see we are just getting this text over here. No padding at the end. So this is something you should be familiar with because you will encounter this quite often. Base64 it's pretty awesome because we can print out binary values that are non-printable. For example, we can print out characters like a new line character. We cannot print out new line characters on our screen because we won't see them. It's just appending a new line. There are other characters which are even less obvious. So Base64 is pretty nice to get back an format, an ASCII format, a printable ASCII format for non-printable characters. And this is quite often used in every kind of application. The only downside to this one is our payload will become a little bit longer. So I guess it's about 30%. So regarding to messages, it doesn't matter. If you're dealing with large files, then Base64 might be a problem. Alrighty? Perfect. So now we know a little bit more about Base64. Let's see if we can decode this text over here. So therefore I'm using echo-n, or maybe this -n parameter. Let's type Udemy and pipe it to Base64. Here we can see we are not having an padding anymore because we are having U, D, E, M, and Y, which is 5, and we're having a new line at the end. So we're having 6 characters and they are probably aligned. If we apply our -n, then we are not appending this new line character at the end, and therefore we are having just those 5 characters. New line can cause a lot of problems. So therefore you should also have knowledge about this one. Alrighty? Okay, perfect. So now let's decode this text and see if we can read this, because if we take this one over here, this text, and if we pipe it to Base64-D, then we get back our Udemy. All right, let's see if this is also the case over here. Okay, let's see, Base64-D. If I made a typo, it shouldn't be that huge because we should have most of the stuff as in plain text if this one is here plain text. So yes, this is what non-printable characters look like on a terminal. These question marks, I mean, we have no clue what value is behind this because it's binary data. Therefore, we are using Base64 encoding to print them out. Okay, so over here we can see it's binary data and we cannot read this. If we pipe this through XXD-P, then we get the hex representation of those bytes, but this helps us or doesn't help us further right now. We could do an entropy analysis on those bytes and then we would see, okay, these are pretty random, which means this text over here is probably encrypted. Okay, we do not know this right now, but we've got the skills to find this out, and therefore I would suggest let's have a look. Therefore, let's go into apps and one challenge to recap all, and let's have a look with JDX GUI into this application. Okay, the first thing I like to do is taking a look at the manifest. Let's see, we are only having one activity. This is also our launching activity, which means this is this activity over here. This is our screen content, okay? Then let's see. The rest looks pretty normal. We are not even using permissions right now. So this app is, it's not that huge in the Android manifest. All right, here we have our main activity. So we can see we've got our familiar onCreate method. We still ignored this part over here. We've got the set content view, which is the layout of this application. And to be more specific, this one over here, whoops. And this one, so this is the layout. It's defined in layout activity main. Then we've got the text view. So this text view might be, yes, this text view is this part over here, this part. Because we can see down here, we are setting this text to a Base64 encoded string. Okay, but before we dive too deep into this, let's see. Beside this, we are having a system out print line encrypted text. So this is interesting. We can see in system out approach, which means we're having something in the logcat. Let's see. ADB logcat and grep-i system out. Here we have it. We have started this application twice, and we can see this one over here, that's in system out. Okay, nothing in or nothing special in there right now. Then let's see, we've got this text view set text. So this is this part over here. And we can see base64 encode to string. All right, this is our text. And let's see what we are using. Oh, well, we are using AES crypto encrypt message. So we are using the return value of a function in our base64 encode to string method. I guess we have to make this a little bit larger, otherwise it's not readable. Okay, so here we have it now in one screen. So we are using base64 encode to string. So the return parameter of this one has to be in string because we are using it within a set text function. Okay, then we've got AES crypto encrypt message. This is a function call. And here we're having this strange byte array. And we're having a second parameter, comma 0. All right, this line is massive, but we can split this up into single pieces because the JDX output is just combining everything into one line. Okay, therefore I would suggest let's do this over here. So we start from the outer brackets and we go to the inner brackets. In this way, we are not messing it up. So here we've got set text. Okay, so let's see. This one over here is set text. Oops. Okay, and then we've got base64 encode to string. Okay, so let's see. Base64 encode to string, these are those brackets. This one, and over here the next one. So these two brackets, which means we can see we are having two parameters in here because we've gotten comma. So this one is our base64 encode to string method, and we are taking two parameters. The first one is this. That's not visible. This. And the second one is this one over here. This is the second parameter of our encode to string method. So within this method, AES crypto encrypt message, let's see. I guess I'm running out of color, so we are reusing red once again. We've got this bracket and this bracket. Yes, so this is working perfectly fine right now. We're not having any bracket left, which means encrypt message is only having one parameter. So let's clean this up over here. Okay, and this is this parameter here. Okay, if we are now going from the inner classes to the outer classes, we can reconstruct how these methods are being called and what's being returned to what. Okay, so let's see. We start with the first one. The first one is AES crypto encrypt message. Okay, this has only one parameter, which is a byte array. Okay, the next one is, it's the color cyan. And this one is base64 encode to string. Okay, we can also take green. So this one is, it's the second one. It's base64 encode to string. And this one is as first parameter taking our return of function 1. So this line over here. And the second parameter is this 0. Okay. And this one is returning back a string, which is being used in text view set text. So this is what happens in this line over here, and I can hear my fan spinning around because also for my CPU, this is absolutely crazy right now. Okay, but we made our way through this. So we've got AES encrypt message. This is the one we are first having a look into this one. Then we will have a look into this one, and then we should be done. So then we should have understood what's going on over here. So therefore, let's have a look into AES crypto encrypt message. Okay, before we go into the AES crypto encrypt message method, maybe one last thing I didn't mention right now. The base64 encode to string has two parameters. This one over here, which we do not know right now what this one is, and the 0. And therefore, we should look it up, that we understand what's going on over here. And the easiest way is if we simply click on this one, then we can see it's from android.util base64. So let's search for this one in your search engine of choice. All right, so here we have it, developerandroid.com base64. Okay, let's see. Here we've got this public class, and on the right we've got those methods. We've got two methods, encode to string. That's good. Let's check them out. The first one is using an byte array, an offset, length, and flex. So we are having 4 parameters in here, which means this is not the method we are looking for. So the encode to string method is being overloaded with a different amount of parameters, and this one is not what we are looking for. Therefore, it has to be this one. So let's see. Perfect. We are only having 2 parameters, input and flex, and we can see the first one is a byte array. So now we know the AES crypto encrypt message function is returning back a byte array. Okay, base64 encode the given data and return a newly allocated string with the result. All right, the base64 method is returning back the string. And this is exactly what we have seen, the base64 string, which can be used in the set text function to get it out on our application. All right. Okay, so let's figure out what are those parameters. The first one is input. It's a byte array in this case, and the data to encode. Okay, that sounds easy. Then we've got flex, and flex is an integer value. Controls certain features of the encoded output. Passing default, whatever this one is, results in an output that adds here to the RFC 2045. Okay. So the RFC, it's a standard, and there it's described how this encoding works. And if we pass in the default value, then we can simply look it up over here. Base64 can be also used with different character sets, for example. But if we're using the default value, then we can be sure that this character set fits with this one over here. So let's see what's default. And we can find this over here. Constants, default. Default is 0, perfect. This means we are not dealing with some really strange character sets in our base64 encoding. We are having a basic base64 encoding, which means we could simply, we could do this on our terminal over here, like this one. All right? Okay. This is something you definitely should up, because in the past I have encountered some base64 formats which are using some really strange character sets, and this will mess up your whole encoding. So this is something you should definitely check out if that's the case for you. All right, now we can get back to the AES crypto message. This one over here, encrypt message, sorry, this way. So we double click on this one, and here we can now see we have an AES crypto class, but this doesn't mean that it is AES. So sometimes developers do some strange things, and we cannot rely on this one. We have to reverse engineer this code. Okay, we've got the method encrypt message. This method is taking a byte array. This is something we have already seen. And it's also returning in byte array. So the first parameter in our base64 method, encode to string, this one over here, this is a byte array. All right? Okay. Then let's see, we've got key generator get instance AES. Now we can be sure that it is really AES, because this key generator comes from the generic class JavaX crypto key generator, and it's getting an AES instance. Then it's initializing this key generator, and then we are having a secret key, generate key. This is pretty interesting. In AES, we have certain parameters or values regarding to the encryption algorithms. In this application right now, we can see that we're using AES in CBC mode. CBC is, I guess, a cipher block chaining mode, but we will have a separate video on AES. So this is some kind of bonus video, because AES, it's a very common encryption algorithm, and you will find this a lot in every type of application, also for Android applications. So there are some neat tricks that can help you out if the developer has implemented it wrong. And this is something we will take a look into the bonus video. Okay, But back to this one. So here we are generating a key, and this key is being used within our encryption. And we can see we are not having an input on this one. We are generating it. This means this key is most likely being generated randomly, which means every time this method is being called, we are using a different key for our encryption algorithms of our plaintext. This is also pretty nice. We can already see the parameter we are inserting in this function is already the plaintext. So the challenge is not getting out the plaintext or the ciphertext. The challenge is getting out those objects. For example, this secret key over here. Okay, first let's verify a few things. So this one is generating a new key, and this one is being generated in this message call over here. If we go back into the main activity, the message or this method encrypt message is called every time we are calling the onCreate method, which means every time we are launching this application, we are using or we are generating a new key for our encryption over here. So this is why it's absolutely necessary to print out this key, this one over here. All right. This will be a task in our one challenge to recap all challenge. Okay, and then we've got this one over here, AES CBC mode. Then we've got cipher init, so we are initializing something with our key, by the way. And then we've got our ciphertext, and that's the text we're going to return. And we can now see our cipher instance, which has been initialized with our key, is now performing the doFinal method on our plaintext. So this is now where the encryption is finally taking place, and we get back the ciphertext. So the encrypted text, which will be returned out of this function as a byte array over here. Okay, the ciphertext will be returned, and this line is also pretty interesting. We can see we have cipher.getIV. IV is the initialization vector, and this is also a parameter which is being used in our AES crypto function, or maybe not being used. And this is also something we have to figure out, if this value which is being generated over here is being used in our AES encryption. Right now, I would assume not, because we have already created our ciphertext over here. But maybe this one is being called in between over here also. So yeah, we will have a look into this one. Okay, and then we've got return ciphertext. So then we are returning out. Okay, and then we've got this try and catch block. So this try block is observing this code path if there is some error occurring. If there's an error, for example, no such algorithmus exception, for example, if you're using an algorithmus that's not known, let's call this Udemy, I guess that's not known in the JavaX crypto class, then this exception will be thrown, and this exception is printing out in stack trace, and this method will return null. So we will go out of this method with the return value null, which will crash later on the whole application. But in this case, it's designed because there shouldn't be an error within the encryption part right now. All right? Okay, so this is all for this part right now. Let's go back to the main activity. And last but not least, we've got this byte array, and we have already seen this is some kind of plain text. And we can also observe this because the number 51, let's see, the number 51 is occurring more often than others. I mean, it's occurring pretty often, and therefore it's most likely not being encrypted, this text over here. So we could simply use a Python shell, and we could restore those characters, or not restore, we can simply print them out by converting those decimal values into characters. So a character of 83 is S. Okay, let's see what's 51. A 3, that's interesting. Then we've got 99, C, and so on. We've gotten feeling what this word might be about, but we could also simply, we could also get back those characters. This is simply just an ASCII table. So if we type in main ASCII, then we get this pretty nice table, and here we have all these representations. For example, the decimal value 83, let's see. 83, here we have the octa representation, the decimal value representation, hex, and also the character representation. 83, there we go, it's in character S. So that's the whole secret behind this one. What's interesting is, what's interesting is the number 51, because the number 51 is an 3. And this is it's the most basic text analysis you could do regarding to cryptography on things like this one. Let's assume we've gotten text and the text has been scrambled. For example, the letter A has been substituted or changed with the letter C. The letter B has been substituted with another value, for example, X, and so on. Within an English text, some letters occur more often than others, for example, E and I. So by figuring out what E and I is, we might get some conclusion what the scrambling is about. For example, a fixed value of 13, rot 13, for example. Rotation, which means we are rotating this character by 13 characters. So this is some kind of basic analysis we could perform on this one. But in this case right now, it's not even necessary because it seems to be clear text. The letter E has been substituted with the number 3, but that's all. So C might be something like secret, and here we can see C, so E, here we have it once again, yes. So this might be secret, this word. All right? Okay, so what is this challenge about right now? We have seen we can get the plain text pretty easily. That's not the point. We have also seen that we can get the ciphertext because this one is being printed out on our screen over here. If we start this application or restart it, then we can see, oh, that's interesting. The input does change because every time we are calling the onCreate method, those key material is going to be newly created. It's being changed and our text will be differently encrypted. And this is exactly what our challenge is about. We need to find a way to get out those information, the secret key and the initialization vector. So the things we need to do is we need to get out within the AES crypto method the key, which is this one over here, and also the initialization vector, which might be returned by this method over here. This is our task and this will be done within the next 3 lessons. So lesson 1 will be about dealing with new Smiley syntax. For example, this try and catch block. We have never encountered this before and we will be able to understand what's going on over here in the Smiley part. I mean, here in the Java world, it might be easy, but Smiley looks a little bit strange, let's say. All right, lesson 2 will be about printing out complex objects. For example, the key out of the secret key object or the initialization vector of this method, however it's being returned over here. So we will learn how to deal with more complex objects. And lesson 3 will be about inserting a huge block of smiley lines into an existing applications, because there we have to consider a lot of things and we have to adjust even more. So that's a perfect ending for our series over here. We do not get really an advantage out of this because everything we are doing in lesson 3, or maybe most of the things we are achieving in level 3, has been already done in level 2. In level 2 we are figuring out on how to print out complex objects, those return values and things like this. Level 3 is more about if you are trying to apply a huge patch into an existing application. I mean, we are not limited to certain classes or methods. We can patch whatever we like, and we can also interact with whatever we like. And this is something we are doing in session 3. In session 3, beside this patching of those return values in a hard way, we will also figure out on how to interact with UI components. And this is freaking awesome. There we will learn how we can interact with existing activities. So we can print out new messages, we can interact with the design, we could change background colors and things like this. Tasks regarding to the UI are not really easy in Android, even in Java, and in Smiley it's even worse. But this is something we will learn in session 3. So my suggestion would be, if you're feeling absolutely comfortable regarding to Smiley right now, maybe have just a quick look into lesson 3 if this is interesting or new for you. And in case if you say, okay, that's easy peasy, I know the stuff, then you can easily move on with the next one, with our SpacePing application, because there we are having even more fancy and nice patches to do right now. Alrighty? Okay. In case if you like to recap certain things, this video series is for you right now. Okay? So therefore, I'm looking forward to see you in the next video.